The last part of Chapter 5 is an important calculation that we're going to be doing quite a bit for the rest of the class. It's called the formula mass or the molecular mass. What this involves is using the periodic table to calculate the mass of one molecule. For example, NH3. The chemical formula tells you that you have 1 atom of nitrogen and 3 atoms of hydrogen. If you look on the periodic table, you'll find the atomic mass of nitrogen is 14.01. So remember from earlier, that atomic mass or atomic weight is the average of one nitrogen atom. So if we had one nitrogen like we do, we're going to have 1 times that value, 14.01 atomic mass units. That's how much the nitrogen contributes to the mass of the molecule. The hydrogen atomic mass on the periodic table is 1.01. Notice we're using the periodic table, we're using 2 decimal places. Some atomic masses go out to many more decimal places. So what I recommend you do is always round these to 2 decimal places. So we have 3 hydrogen atoms. Each one has an average of 1.01 atomic mass units. And if we add that to the nitrogen, we'll have an answer of 17.04 atomic mass units. That is the molecular mass. So that's the mass of one molecule of NH3. NaCl, we would do exactly the same way. So you don't have to write down the number of each that you have. You can just look at the formula and know that you have 1 sodium atom. So that's an average of 22.99 atomic mass units. And 1 chlorine. Periodic table tells you that's 35.45 atomic mass units. So this molecular mass is much heavier, 58.44 atomic mass units. It's made up of only 2 atoms compared to NH3, which had 4 atoms, but obviously these atoms are much heavier. And sometimes you'll be given the chemical formula in its name, and you'll have to figure out the correct number of each. So if you're given the name aluminum sulfate, you can tell from the naming that we're not dealing with an acid, because there's no word acid in the formula. We're not dealing with a molecular compound, because there's no prefixes in the name. So this is an ionic compound that comes from the aluminum cation, which we know from the periodic table, being in group 13, a main group metal in group 13, aluminum will make a positive 3 cation, and sulfate, we memorize from table 5.3, is SO4 with a negative 2 charge. So we have to do the crisscross work first in order to figure out the right number of each element in this formula. Do the crisscross, we need 2 aluminums for every 3 sulfates. So when we calculate the molecular mass, we're going to have 2 times the value for aluminum, which is 26.98 atomic mass units, 3 times the value for sulfur, 32.07, and remember, we have to multiply the 3 times the 4 to get 12 oxygens total, and oxygen's atomic mass is 16 atomic mass units. So this totals to just over 342 atomic mass units.